Good day, my dear students. Welcome back to my channel, Otababa Music TV. And for today's video tutorial, I'm going to teach you how to combine radical expressions. But before we proceed, don't forget to subscribe and hit the notification bell so that you will be updated for my next video tutorial. Okay, so today we're going to learn how to combine radical expressions. Radicals are either rational and irrational numbers. Like rational numbers, this form of irrational numbers can be combined, multiplied, and divided. Similar or like radicals are those expressions of the same order and having the same radicands. Thus, square root of 2, 3 square root of 2, negative square root of 2 are similar radicals because they have the same order, that is 2, and same radicand, that is square root of 2, while square root of 3 and cube root of 3 are not similar radicals, since they have different orders. Similar radicals can be combined by addition or subtraction. So the rule in combining radicals, only similar radicals can be combined. To combine similar radicals, add or subtract their coefficients and annex their common radical. So the steps in combining radicals, first you are going to simplify its radicals. Then, to add or subtract radicals, the indices and what is inside the radical, called the radicand, must be exactly the same. If the indices and radicands are the same, then add or subtract the terms in front of its like radical or coefficients. If the indices or radicands are not the same, then you cannot add or subtract the radicals. Okay, so for example, we're going to add 2x cube root of 16x plus 5 cube root of 54x to the 4th. So these radical expressions, based on the index of the root or the indices, they are similar radicals, but they don't have the same radicand. So what we're going to do, we're going to simplify these radicals. So first, 16. We're going to think of a number in which when we multiply it by itself 3 times, the result is 16. Or we can do this also by prime factorization. Okay, so 16 is equal to 2 times 8. Then 8 still can be factored by 2 times 4. And then 4 can still be factored by 2 times 2. And then we're going to get the prime factors. So the prime factors are 2, 2, 2, and 2. This one. So we will get 3 2's here. So we have 3 2. So 2 times 2 times 2 is a perfect cube. So 2 times 2 times 2 equals 8 times 2. So therefore, the factors of 16 in which one of the factors is a perfect cube is 8 and 2. We will do the same also with 54. So we will do prime factorization for 54. So 54 divided by 2 is 27, so that is 2 times 27. Then 27, it is divisible by 3, so 27 divided by 3 is 9, so 3 times 9. The 9 is still factorable, that is 3 times 3. And then we will get the prime factors. So first we have 2 times 3 and then times 3 and times 3. Okay, so three numbers which are the same is 3. So that is 3 times 3 times 3 is equals to 27. So 2 times 27 are the factors of 54, in which one of the factor is a perfect square, a perfect cube number. Then x to the fourth is also factorable. So when we expand that, x to the fourth times x times x times x. So we will get 3x's here. So x cubed. So x cubed is a perfect cube. So the factors of x to the fourth, in which one the factor is a perfect cube, is x cubed times x. Okay, so here we go. So we have here now 2x cube root of 8 times 2x. So 8 is a perfect cube. Plus 5 cube root of 27 times 2x cubed times x. 27 is a perfect cube. And x cubed is a perfect cube. Then we extract the cube root of 8. And this is now 2. So 2x times 2 cube root of 2x. Plus, we extract the cube root of 27, that is 3. So 5 times 3, x cube root of 2x. Then we multiply the coefficients. Okay, here we go. So 2 times 2 is 4, copy x. Cube root of 2x plus 5 times 3 is 15, copy x. Cube root of 2x. So now these radicals are similar because they have the same order and the same radicand. So the radicand is 2x and the indices is 3. So we combine, so 4x plus 15, so that is now 19x. So this is our final answer. Okay, so another example. So we have here 2 square root of 32x squared minus 5 square root of 27x to the fourth. So we examine the indices. We have 2 here and also 2. So by the orders, they can be considered similar. And after we simplify the radicand, we will try to find out whether we will arrive with similar radicals so that we can subtract the coefficient. So what we're going to do first, we're going to factor out 32, in which one of the factor is a perfect square number. So what we're going to do, we will do the prime factorization. So 32 divided by 2 is 16. So that is 2 times 16. Still 16 is factorable by 2 or divisible by 2. So 16 divided by 2 is 8. So 2 times 8. And then 8 is still divisible by 2. So 2 times 4. And then 4 divided by 2 is 2. Okay, so we will write down now our prime factors. So we have here 2 times 2 times 2 times 2 times 2. Okay, so we will get the perfect square number. So we have here 2 times 2 is a perfect square number, and 2 times 2 also is a perfect square number. So we have 4 and 4. So 4 times 4 is 16. So 16 is a perfect square number. And then we copy 2. Okay, so therefore, the factors of 32 in which one of the factor is a perfect square number is 2, 2 times 16. Okay, next we have 27. So we will factor out 27 in which one of the factor is a perfect square number. So what we're going to do, we will do a prime factorization. So 27 divided by 2 cannot be. 27 divided by 3 is 9. So 3 times 9. And the 9 is still factorable. So 9 divided by 3 is 3. Okay, so we will now get our prime factors. So we have 3 times 3 times 3. Okay, so we have 3 threes here. Then we will get two numbers, which is multiplied by itself twice is a perfect square number, and that is 3 times 3. So 3 times 3 is 9, then times 3. Okay, so therefore, the factors of 27 in which one of the factor is a perfect square number is 9 times 3. Okay, so here we go. So we have here 2x square root of 16 times 2 minus 5 square root of 9 times 3 x squared times x squared. These are the factors of x to the fourth in which one of the factors is a perfect square. But x to the fourth is already a perfect square number. Okay, so we extract the square root of 16, that is 4. Then we also extract the square root of 9, and that is 3. Then we multiply 2 and 4. We also multiply 5 and 3. So 2 times 4 is 8. 5 times 3 is 15. The square root of x to the fourth is x squared. So we copied the radicals. So square root of 2 here and square root of 3 here. Now, as we notice, Though they have the same index of the root or indices, but they don't have the same radicand. So these radicals are not similar radicals. Therefore, we cannot combine them. We cannot subtract. So the answer is still 8x square root of 2 minus 15x squared square root of 3. This will be now our final answer. I hope it is clear for you in combining radical expressions, that is adding or subtracting radical expressions. We can only add or subtract radicals if they are similar. When we say similar radicals, they have the same indices or orders, and they have the same radicals, rather radicand. So if they are not similar radicals, then we cannot add or subtract the radical expression.